Welcome to this explainer. Okay, today we are going to unpack one of the absolute most fascinating battles happening right now in the global electric vehicle industry. Think of it as the ultimate David versus Goliath story. On one side, we have an entrenched, near impenetrable global monopoly controlling the actual materials that make electric vehicles go. And on the other side, we have an incredibly ambitious startup that's basically trying to rewrite the rules of physics using software. They are armed with an arsenal of just 5 key patents to wage this war against a global monopoly. It's a super high-stakes race, and honestly, the outcome could completely reshape how we build the cars of the future.
I mean, it sounds kind of absurd when you put it as a direct question, doesn't it? Can a $5 million startup genuinely solve a massive geopolitical crisis? Because right now, multi-billion-dollar legacy automakers are scrambling. I'm talking massive R&D budgets, and yet they've been largely stumped by this geopolitical chokehold on critical minerals. But there's this small pilot stage team based out of Bengaluru, India, that firmly believes they can outsmart this entire supply chain bottleneck. To really grasp how audacious their claim is, we first need to understand the sheer scale of the problem they're trying to solve. So let's dive into it. 80%, over 80% of today's electric vehicle motors rely on rare earth magnets to function. Whether you're driving a super high-end luxury EV or just a standard daily commuter, chances are the motor physically turning your wheels depends heavily on these highly specialized, incredibly powerful magnets. They are the baseline standard of the entire industry. But you gotta wonder, why? Why are automakers absolutely addicted to them? Well, to answer that, we have to look under the hood at the technology itself. Most EVs out there use what's called a permanent magnet synchronous motor, or PMSM for short. These motors use heavy rare earth elements, specifically metals with names like neodymium and dysprosium, embedded directly into the motor's rotor. Think of these rare earth elements as the absolute secret sauce, right? Or like the steroids of the EV motor world. They provide this incredible thermal stability and an unmatched power-to-weight ratio. They are literally the reason modern electric motors can be so compact and light, but still deliver that instant thrilling torque and the massive battery range that drivers expect. But, as you might have guessed, there is a massive catch to using these magical metals. Here's the catch, and it is a huge one. China currently controls a staggering 91% of global rare earth refining and separation. Now, what's really wild about this is that China only holds about a third of the world's natural reserves of these metals in the ground. So their true monopoly isn't actually the mining itself, it's the processing. They have spent decades building this highly complex, environmentally sensitive infrastructure required to separate these elements and turn them into finished magnets. The rest of the world combined, we account for just 9% of the refining. And this monopoly isn't just theoretical, it is an active weapon. Let's look at the timeline. Back in 2010, a diplomatic dispute led to a massive supply crisis in Japan, sending rare earth prices skyrocketing by over 2,000%. Fast forward to April 2025, and strict export controls were imposed on 7 heavy rare earth elements. Then in October 2025, they introduced a 0.1% de minimis rule targeting foreign-made products. Basically, this meant even a tiny, fractional trace amount of Chinese rare earth content could subject foreign products to their trade rules. Now, actually, that October rule was temporarily paused as part of a trade truce, but the message was sent loud and clear. Western and Indian automotive markets practically went into a panic, waking up to the fact that their entire EV roadmaps were entirely dependent on a single nation's trade policies. So, how do you fight a monopoly like that? Well, if you're a legacy automaker, you just throw an absolute fortune at alternative engineering. Tesla, for instance, who originally popularized rare earth-free induction motors, has vowed to shift their next-generation permanent magnet motors entirely away from rare earths. BMW has actually already commercialized an alternative called the externally excited synchronous motor in several of their current models to eliminate rare earths completely. Meanwhile, giants like GM and Stellantis, they've taken the investment route, pouring millions into startups like Iron-nitride to develop new, clean earth magnets made from superabundant stuff like iron and nitrogen. But here is the harsh reality check. Everyone is throwing money at the wall, but a silver bullet still remains completely elusive. A highly efficient, perfectly mass-produced alternative that actually matches the cost and performance of those rare earth magnets, it just doesn't exist at scale yet. The legacy alternatives often suffer from lower power density, which means they are heavier, or they suffer from efficiency losses at certain speeds. Long story short, the industry is desperately looking for a real breakthrough.
All right, enter the David of our story, Vimag Labs. Instead of relying on physical, fixed blocks of metal shoved into a rotor like a traditional motor, Vimag's virtual magnet eliminates that hardware entirely.
Their virtual magnet synchronous motor, or VMSM, replaces those fixed rare earth chunks with something totally different. Instead, it generates and controls the magnetic field dynamically, in real time, using power electronics and highly advanced control algorithms. This is honestly a brilliant conceptual leap. Vimag realized that trying to rebuild this incredibly complex, multi-billion-dollar rare earth mining and refining supply chain in India or the West, well, it would literally take decades. So they looked at that supply chain and essentially said, no thanks, we'll just write some code instead. They're bypassing the hardware supply chain entirely by replacing it with software. They're taking the rarest metals on Earth and substituting them with lines of code and standard, abundant copper.
So how do you actually create a virtual magnet? Let's break down the steps. First, they utilize standard copper coils in a brushless design, which means there are no physical brushes grinding and wearing down over time. Second, they run incredibly fast proprietary software algorithms. And third, those algorithms precisely regulate the direct current flowing into those coils. So instead of a permanent magnet that just constantly exists, Vimag's software creates an electromagnet that perfectly modulates the strength and direction of the magnetic field exactly when and exactly where it's needed. It completely avoids that continuous massive electrical energy drain that typically plagues older, less sophisticated electromagnets.
And this brings us to their ultimate weapon, which we call the 5-patent competitive challenge. While the legacy giants have billions in capital, Vimag has completely ring-fenced their software bypass with 5 granted Indian patents. This intellectual property is their protective shield. It ensures they can challenge the Goliaths of the industry without having their tech instantly copied. And that's just the start. This core architecture is backed up by another 10 patents in the pipeline, representing over 87,600 engineering hours invested into perfecting this code. They're even targeting massive industrial systems, up to 600 kilowatts. We're talking robotics and defense here, not just passenger cars. And clearly, the broader tech industry believes in their trajectory because it was just validated by a recent $5 million Series A funding round, led by the major venture capital firm Accel.
But you gotta ask, why is this so difficult to pull off? Well, it's because of a razor-thin margin for error, 0.1%. When you rely on software and electromagnets instead of permanent rare earth magnets, your system must be absolutely flawless. In an electric vehicle, even a marginal 0.1% drop in the efficiency of the motor drive has these huge cascading effects. A less efficient motor drains the battery faster. To maintain the same driving range, you'd have to add a heavier, more expensive battery pack. And guess what? A heavier battery requires even more energy to move, creating this vicious cycle of inefficiency. Vimag's software literally has to thread the needle perfectly to match the efficiency of those magic metals.
Which is exactly why the industry isn't quite popping the champagne just yet. As noted by the EV publication Electric, quote, "We take the matches or exceeds claim with caution until there's independent bench data." And they hit the nail on the head. We have to remember that motors that shine brilliantly in small pilot stages or controlled lab environments often face absolutely brutal, sometimes insurmountable challenges when they hit mass volume automotive production. The cost, the durability, the extreme thermal testing. Vimag has to prove this works not just in a prototype, but in millions of cars driving in the blazing heat, the freezing cold, and the pouring rain for a decade. And the stakes for getting this right are unbelievably high, especially in Vimag's home country. Zooming out to the broader context for a second, India currently imports roughly 90% of its rare earth magnets from China. 90%! To secure its own EV future, the advisory firm Primus Partners recently proposed a massive 5-pillar strategy to create self-reliance in India, heavily focusing on building a national rare earth innovation hub and accelerating R&D. The ultimate goal? To entirely de-risk the nation's EV manufacturing. Because think about it, if a nation's EV manufacturing can be completely derailed by a single import, the entire green transition is at risk. Innovations exactly like Vimag's virtual magnet are the specific kind of domestic intellectual property India so desperately needs to break free from that import dependence. So we are left at this incredibly fascinating crossroads. The legacy giants are out there trying to engineer their way around their rare earth supply chain using massive piles of capital and alternative metals. But a tiny startup in Bengaluru is betting that the ultimate solution isn't found in a mine at all, but in a microprocessor. Can software truly replace the rarest metals on Earth? Can a $5 million startup armed with a 5-patent challenge actually survive the brutal leap to mass production and reshape the entire EV industry? It is a monumental challenge for sure, and you can bet the whole automotive world is watching closely. Thanks so much for joining me on this explainer, and I highly encourage you to keep a close eye on how this incredible technological race unfolds.